Welcome, everybody, to the ConTech Exec podcast. It's 2026, and man, it's gone by so quickly, but I am very, very lucky. I've got a great guest here today, and I just kind of want to start this out. Look, folks, it's 2026. We are staring down the barrel of the age of AI, money committed in the trillions of dollars. We're talking about data centers, energy infrastructure, water considerations, thousands of skilled labor jobs going to be needed, not to mention the project management jobs that are going to be needed. And we're fully committed, it looks like, to invest in technology and digital systems and AI. So we've been sold on this idea, but yet somehow we're 30% less productive than we were in 1990. And I've got the best guest here today to talk about this and get this kicked off. Today, I've got Todd Zabelle from Strategic Project Solutions, and he's also the founder of Project Production Institute. Man, Todd, thank you for being here today. I can't wait. I'm so excited to start 2026 off with you.
Robert, thank you for having us. This is a truly unique opportunity, and very excited to get into it.
Yeah. So we're not just going to get into today. This is the exciting news about it. What I like is we're going to do about 3 of these episodes because there's so much to talk about, and we don't want to just glance off of one issue in 45 minutes and try to get all 3 in. So we're going to do 3 episodes of these, and want everybody to kind of stick around, pay attention to what's going on. I'll be sending out copious notes of what we're going to talk about, and then get you ready for the next episode that comes up. So it'll be it's going to be really informative. And kind of the first thing I want to start off with was kind of what we were looking at. We've got construction has a problem. It doesn't really have a problem. It's got a flow problem, I guess. But we're start talking about all these big projects like data centers and energy infrastructure projects and things like that. And notoriously, we've just been really, really bad at being productive, I'll say, at getting them done on time, on budget, those types of things. So kind of tell me, where are we going off the rails on this stuff? And, from your experience, what are some solutions here?
Yeah. So let's talk about how we got here. I actually had this question posed, and for those that read Built to Fail the book, they would see this story, but I'll repeat it because I think it's important. We were doing some work for a very large oil and gas company, energy company years ago, and Joe, who ran the capital program in their city, how did we get here? Everything that they had going on was significantly over budget and over cost. And they really couldn't get any line of sight when some of these things would even be done. I'm talking massive, massive projects, right? And so, I took that with basically some opportunity to go think about this, and ended up reading about 30 books in 2 months, and just really began to see something that I don't know if a lot of people understand, but we like to say that there's been 3 eras, ERA, of how we look at project delivery. And really, era 1's rooted in what we call the Taylorism, scientific management, where the underlying belief is that if we have everyone working as hard as possible, we will get done fast. Now, you brought up the word flow, and that's really interesting. Technically, if there's any variability between how fast it takes you and how long it takes me to do a task, and we're in any kind of handoff or handover, right? If you go faster than I do, then things are going to stack up between us. If I go faster than you, I'm going to be waiting. So we're not going to maximize flow if we're both working as hard as possible. But that's what Taylor brought us. And Taylor also invented many things that we use today. Henry Gantt worked for him, so the bar chart, piecework. He paid workers, right, for getting work done by the piece rather than by the hour. He had these 8 functional foremen, and so on and so forth. And the key thing there is we built upon that. Now we're talking over 110 years ago, right? At the beginning of the last century.
That's what I was going to say. Yeah. These are very, very old concepts.
Yeah. If you're doing time on tool study, you're using a bar chart. If you're paying unit rate contracts, you're basically doing things that Frederick Taylor talked about way back in the turn of the last century. So, we get to the middle of the last century, maybe into the 60s, and the U.S. Department of Defense decides that, hey, we got to get more predictable in our projects because we have to go get appropriations from Congress. So we have to tell them what we have going, right? Mm-hmm. So now we bring in things like critical path scheduling. We bring in PERT analysis, later earned value management. At the same time, they're trying to figure out how do we account for all this stuff, right? So percent complete accounting, which is a really interesting concept. If we have $100 to spend and we spend 80, we believe we're 80% done. And guys like you, you're already laughing, right? So we call that era 2, this era of predictability. So we've gone from productivity, era 1, Taylorism, era 2, predictability. We're trying to predict what's going to happen. Maybe not a bad thing. You'd like to know what's happened, to what we now call the era of profitability, or that maybe starts with the lean movement that's gone a little bit of different direction than perhaps those of us in the beginning saw that happening. But I'll come back to it for a sec. So what we did is we overlaid productivity curves, not only the ones going back that Stanford had produced that so many people love to show, but also if you go through the Department of Statistics and the Department of Labor through the U.S. government, it shows there's been no productivity improvement in construction from the turn of the last century. This is all public information.
That is correct.
We then looked at it and we said, let's overlay these three eras, right, and see what's happened in each era. And you can see it's just dead across. Manufacturing's taken off. There's reasons for that. We can get into that later. The point is, when you start to think about, and this word flow is really interesting, because a lot of people don't know what that means. It's like a feel-good thing. Yeah, it's like it's flowing. It's a good project, right? That's actually a very, very technical term. And the opposite of flow is inventory or work in process, not progress, work in process. Okay, so let me just tie all this together for you.
Yeah.
If we are trying to get people to work as hard as possible, we're paying them to work as hard as possible, and we're measuring progress based on how much we spend. And we've been on projects where they actually have charts up that say burn and earn, right? If we burn money, burn hours, we earn progress. We have a recipe to create mass amounts of work in process. Work in process is the opposite of flow.
Flow, that is right. Yes.
Things are either waiting to be worked on, being worked on, or waiting for the next step, which is basically waiting to be worked on again, right? So you've brought up a very, very scientific term in the world of production called flow that we can mathematically model. But what I hope people begin to understand or see is the opposite of flow is the buildup of WIP, which is a special type of inventory.
Right.
So let me just one last thing. So what we do is we work very diligently to build up the WIP. Now, the key thing with WIP is WIP's the proxy for time. If you want to know how long it's going to take and you're going to predict, we measure the WIP.
Right. So it's funny. I know there's a lot of folks out here maybe listening to this podcast, been on the job site, ran crews before, and I don't care, large or small. But they always know that you get a set of electricians in a room with a set of plumbers and you get them in there with some framers and they all start tripping over each other. You start to see the job go to shit in a heartbeat, right? And they see that. And so the light bulb moment for me was, and I may not have known the technical term of flow at the time, but it was like, this ain't going right. I've got too many people in the area, even though they may be getting what they need to get done. It would be better, right, if they were actually getting it done and then the next thing moved in right behind them, because there are areas where, to your point, most of the time, the losses come from guys just waiting around or, not being able to get in where they're supposed to be. Right. It's one of those things. And that's what flow is. Flow is the smooth transition from the way I understand it, the smooth transition from one project to the one product to the next in order to get maximum out of that production time, that work in progress, right?
Process. Yeah. So it's interesting. You've brought up another really interesting point. And so the question here is, what is the size of the transfer batch? Let's take it's a building. Are we given a whole building from mechanical, electrical, a whole floor, a room, a portion of a room? Again, that's a mathematical problem that we can solve for. And if we give too big of a batch, and many specialty contractors, I used to be one, give me the whole thing, I can go as fast as possible. Absolutely. But if we give everyone the whole thing from the owner's perspective, the time just keeps going out, right? So you can go faster because you're quarantined, but the whole project's going out because the WIP's going up, okay? If we give them too little amount of work, then we're stacking people on top of each other. And basically we get what they call in oil and gas simultaneous operations. Someone's going to get injured, right? So we don't want that either, okay?
Right.
So what you're talking about here is, again, another scientific question, which based on a specific project and what needs to be done, what is the optimal transfer batch size between the trades on the handoff? And it may be different for an electrician than a pipe fitter, than a wallboard guy, than a painter, than the carpet guy, right?
Correct.
And then there's technical constraints to that, which in manufacturing, they work very, very hard to solve for because they have basically, let's call it somewhat standard products to a certain extent. Not that we don't, because we do, and that's a misnomer.
Right.
But we want to solve for that but we can't always do it by the design, if you will, right? We
Correct.
got to do it more from a process perspective. So the transfer batches you're saying is a really critical element. How big is the handoff? And we can't make everybody happy. But if I was the owner, I would say, hey, the ultimate thing here is for me. And if I need to pay extra, I probably should do that.
Right. I think that's interesting too, because we start talking about that transition and it's always been people try to look at manufacturing but construction guys over here saying, well, we're not manufacturing, we're all snowflakes. We've got but yet at the end of the day, we put out many of the same products. It's just a matter of scale. If I'm laying out a steel stud wall, right, I really couldn't care less how many linear feet I've got. Is it 20 feet tall? Is it 10 feet tall? It's still steel studs. It's still the same kind of thing, right? Now you can degrade. If you want to, you could start measuring grains of sand on the beach, but you don't really have to. You can get a pretty good idea. You're hanging metal studs. Now, are you hanging heavy gauge metal studs? That might be a little bit different, but there's slight adjustments that you can make for each one. Everybody knows this, but then they don't treat it like that, right? So they don't treat it like manufacturing. I think that brings up the term variability. Right. It's the enemy. So kind of like, how does variability translate into construction for these guys to kind of wrap it around their heads?
Okay. So you got a lot there. This is interesting way you go about this. You threw a lot on the table. So let's start off. First of all, if we get to the lowest common denominator, which is, like you said, we need to take some standard work and we are going to measure, cut studs, put the studs in place, and either tack weld them or screw them in. We all know that if we had anything to do with any kind of commercial construction, that's pretty straightforward. Okay. So that process is the same. Now you're saying, hey, what if it's a 12 gauge versus 16 gauge versus a 20 gauge stud? Maybe it's stainless versus galvanized, depending on the situation. Well, it may take longer to cut it, may take longer to screw it in, may not be as forgiving. So the cycle time goes up, but the process doesn't change. So a lot of the work that we do when we get it down to the lowest common denominator is standard work. As a matter of fact, you and I were playing around a while back, and remember we typed in on ChatGPT and on Claude, we said, hey, give us a process to do something. And if we put in a stud wall, it would give us exactly that. Now, it didn't invent that. It just went out and queried the web and came back and said, here's how you would do that, right? Okay. And James Jewett, one of my colleagues, says this all the time. You couldn't have trades that you educate people in and train them. You couldn't have engineering disciplines if you didn't have standard work. I mean, we all know how structural engineers work, what their process is to get there. Well, we shouldn't say all of us, but many people know. Okay. So this concept of standard work is really something that's been lost. And I believe, and I don't want to go on the soapbox yet, but one of the themes that I try to get across is I think we've forgot how to do work and we focus on other things, right? Now, let's talk about variability. What people think uncertainty and lack of predictability is variability. The variability that we believe is the most interesting is what we mentioned earlier. If it takes you longer to do it than me, or vice versa, and we're in a chain, that is variability.
Okay, I got you.
All right, get that. So let's say you're going to cut the studs, and you can cut a stud every 30 seconds, and it takes me a minute to put one in. If you keep cutting, we know they're going to stack up.
That's right.
If you cut it in a minute and it takes me 30, well, let me get the reverse of that. If we do it in reverse, I'm standing around waiting for you.
Correct.
That variability, when you start to stack it up through many, many people on these larger projects, many supply lines coming in, gets very complicated. And then we start to create what we call the matching problem, which is the site delivery coming in that is coming at different times. The work's occurring at different times. What can we do about that? This is what the guys at Toyota figured out that people are enamored with, but they don't fully understand what that strategy was. If we pool and we don't have to predict when things might happen to create the match, and we could say, I want to have, the rule is if you cut the stud and I install it, there's always a stud in between us. You're cutting one's in between us, I'm installing. If you're not keeping up, I just stop working.
Yeah.
So that's the variability. And by looking at that variability, or rather by looking at the WIP, the queue between you and me, then we can begin to see, and that queue can be negative, I'm waiting, then we begin to see that where that variability is causing the WIP to build up.
So I compare this back to I'm an old farm kid. So, days of baling hay, right? So
yeah.
I was a young man and I was always the guy that got voted, hey, you got to go into the loft. So I was always the guy at the very top of the loft stacking the hay and into the top of the barn. Well, there's 4 guys on the ground, throwing up bales. And then there's just me up at the very, very top where it's hot as hell. I can't
Yep.
move very
Yep.
well.
Yeah.
And I would get overloaded, right?
Right.
I would like, you guys got to stop. I can't, I got to
Right.
move all this stuff around to get to this other stuff that you've done thrown up on me. And I've got to, stack all this in here. We could not get all the work done. We weren't done with what we were supposed to be done until I was done. This is exactly what you're
Right.
talking about. We're not,
Exactly.
our cycle wasn't very good, I guess to say, because everything was waiting on me. I was the bottleneck, basically.
Okay. Hold that thought, because you're getting some great concepts out here. So we can only go as fast as the bottleneck, and there's always a bottleneck. And what people try to do is remove the bottleneck. You cannot remove the bottleneck. It's not possible. There will always be a bottleneck. So the question becomes, where should we put the bottleneck? And then we use the bottleneck as the throttle.
Okay.
Now we could say, hey, look, in that particular situation, we're going to put 2 guys on the top and 2 on the bottom. Still, some of them are going to be a bottleneck. If we want to predict how long it's going to take to do stuff, we can only go as fast as the bottleneck. If we multiply the bottleneck rate by how much we have to do, we now can reliably predict how long this is going to take. You said something fascinating. You said it's not really that complicated. It's actually not, because if we take the bottleneck rate multiplied by how much we have to do, aka the demand, we now can get very reliable prediction, right?
Yes.
And that's what people are trying to figure out. As you're saying, you start off with critical path scheduling. We can't figure that out with critical path. It's of limited information to know what the sum of the longest activities are in a schedule. What's interesting is, where does the bottleneck occur? What's the bottleneck rate? And how much stuff do we need to run through the bottleneck? And then we could use the bottleneck as a valve to control the flow. So now you've got some serious concepts you put on the table. Flow, and then our bottleneck is what's going to impede the flow, along with variability between the stations, and we can control the bottleneck.
See, I think this is where a lot of folks get it wrong. And it's to your point of, they always want to, oh man, we need to get rid of the bottleneck. We need to get rid of the slowest, part of this process, and just get out there and get it done, hit it hard, get it done as fast as we possibly can. And I think this is where a lot of folks get it wrong. And they're looking at the bottleneck as it is an impediment, yes, but it could be a good thing or it could be a bad thing depending on how you use it, right?
Exactly.
And I think
where you locate it, how you buffer it to protect it,
right, what assets you throw at it is probably another area there.
Yeah, and if you take the bottleneck away, it's going to move somewhere else. Okay. Now, another concept we want to throw out there, and I don't want to get too technical here, but you can only buffer using either inventory, and that's what the grocery store has. You expect to go in there and get lemons or steaks or whatever you want to go get, or you could buffer with capacity, and that's kind of the butcher shop part. They got a big piece of meat and they'll cut you a steak, right? So they have a raw inventory buffer of, let's say, a tenderloin or a big beef rib thing, and they're going to cut you off a ribeye. Okay, so they have the inventory and the capacity. Now, in a service-based industry, engineering, construction management, and a lot of specialty contracting where there's not products made, you can only buffer with capacity, because you can't have a series of steel erected, completed on the shelf to deliver to your customer. So what happens is, we want to protect the capacity, our labor, and our equipment. So we build inventory and we push for the biggest handoff possible to protect ourselves, because that's what impacts our business. That's not wrong for the specialty contractor, but it's really bad for the owner, because their project and their revenue is being extended.
Yes.
And it's really important for the owner to understand the value of compensating the specialty contractors to align with what they're trying to do with their revenue, which oftentimes is antagonistic to the specialty guy and his capacity.
I think that's an interesting point, and it's not to kind of get off the topic of, what we're talking about here in flow, but I think it's an interesting point when we start to interject I'll say the anticipation or the expectation of client. They have a lot of clients out there. I won't say who they are, whether they're big clients. They have unrealistic expectation. They love these critical path management, charts that show, well, according to this, it's supposed to be done here. And that is, the grand grimoire of, exactly how this thing's going to go. There's an example here, just, South Texas, a very, very large client was building a very, very large facility with a very, very large, contractor. And the timeline was just absolutely ridiculous, and then the said owner would say, oh, it's going to be done in 2 years, well, it's not even possible, because the machines that it needed to create the number of just, foundation pieces, they didn't exist. There weren't enough machines to make that happen, right? There wasn't enough asset, as to your point, wasn't enough capacity in the world to do that. But yet they would stick to this idea that they've got this, well, this is supposed to be done in 2 years. It says it right here, right on the schedule. I put it together for you. It's all here. What do you think about that? Because especially as it relates now to what we're looking at in need for data center, need for energy and infrastructure, those kind of things. It really creates a kind of a collision, as far as I can tell.
Yeah, and that's a great point. So first, I think we've entered era 3. I just want to announce that as we talk about production systems. Okay, so we went from era 2, and you said, so we have this era 2 critical path. What's the era 3 view on that? And I'll give you this. One of the things that we began to understand, we've been on a journey too. I've been on a 30-year journey personally in this whole thing, maybe 35 years on, to try to understand this stuff. We need to bifurcate or separate the schedule from the production system. And there's a lot of confusion out there on what the production system is. So let's just talk about this for a sec. The schedule sets the demand of what we need done by who, when. It just says we need to go hang X amount of steel, have that true up, welded, inspected, whatever the case may be. And we think we would like it at about this particular point in time. We know through doing plan percent complete, let's say on the last planner approach or production control, that if we put 10 things on a plan for tomorrow, 5 are going to get done. Okay, so we're 50% reliable in 24 hours, and we're going to predict out 13 months from now when we need something. Okay, so it's very difficult to predict. The rule is the further looking, the more detailed, less accurate. You know that. Okay, and you've lived that, right? So, but we need a schedule to tell us what the demand is. And really the most interesting part of the demand is the bill of materials, more so than this critical path thing, right? And a lot of schedules, to me, I used to be really intimidated when I first got in this whole thing. And the more I learned about it, I go, this is kind of all obvious technical stuff that really the production part's the interesting part. Now let me slip to the production system. The overall production system for the project is all the entities that do work. So what does that look like? Humans, engineers, craft people, right? It could be fabrication equipment, logistics equipment, right? All that stuff through the value chain is the production system. Now we could chop that thing into sub production systems all the way down to what we're talking about, the production system to do the stud wall, and all the way up to the metal level end to end of the project delivery. The production system operates in a different world. Schedules try to predict dates. Production systems operate on rates. And that's why you said earlier, the stud wall is a stud wall. Yeah, there's some variations of it. Great. Okay. We know we can measure. It takes so long to cut it. It takes so long to put it in place, takes so long to screw it in, right? Once we have those rates based on that particular situation, we can now predict how long it's going to take. That's the production system thinking in rates, which is different than the schedule talking about dates. Now, one last word on this. The production system will always dictate what will happen because it is reality.
Yes.
We can make it better. We can say, hey, we're cutting the metal studs with a hacksaw, and maybe we should use a chop box or some other type of thing. Sure, we can make it better, but at the end of the day, those decisions drive what's going to happen, not a guy messing around with a critical path schedule.
Yeah. I think in our last conversation, you and I, when we were just chatting, we were talking about sometimes it's better to go to that supervisor who's got, 20 years of experience, because he could probably just look at a job and go, yeah, it's going to take about this long, right? He's got an innate knowledge of just being there and having done it time after time after time of, your date is probably a little off because I've only got this many guys. I know how we're cutting this material. I know how long we're going to take to put this in. Yeah, you're either on or you're off. And it's strange how that works. But again, I think what you said is spot on. It's not about dates. It's about rates. It's not about what you put on a piece of paper. It's about what you're putting into the job.
Yeah. Let's go back to the farm. You could, you know, whoever was in charge, your dad could have went out there and said, "Boys, we're going to get this done by tomorrow." Great. That's a date.
Thanks, Dad.
And you can sit there and say, you know, they're throwing up a piece every 30 seconds and I'm getting one in place every 2 minutes.
Yeah.
And we've got 1,000 pieces times 2, that's 2,000 pieces. Now, you know, we're not getting done. So either we have to do this era 2 rebaselining, and dad has to say, hey, well, I'll give you two extra days, but that's not cool because I got something going on. Or you got to say, well, maybe we got to find a different way. Maybe we got to get some mechanization. Maybe we got to get some more people. Maybe we need to resort what we're doing. So you can't improve. You could never improve a schedule, right?
Right.
It doesn't really work that way. You improve the production, and the production is a function of the bottleneck. And you said it. In the hay situation, right? You were the bottleneck. So as long as you go as fast as you were, times how much stuff had to move.
That's right. Yeah.
It's
I was
simple.
always begging for a few more assets. You know, it's like, hey, put somebody here in the middle to kind of sort some of these out here for me. You know,
you were hoping for a rooftop conveyor like they load roofs with. Yeah.
I'm going to be honest with you. And so this goes back to the whole flow thing, because a rooftop conveyor, I've worked with the rooftop conveyor before, and those are even worse because they could actually move a hell of a lot more bales up that rooftop conveyor. And it still just relied on me to get it up there and stacked. So I totally get that.
Yeah, that makes sense.
And that's flow, right? You know, that is at the end of the line. I'm the bottleneck. I'm the guy. You can't increase my valve anymore. I've only got so much capacity, right? I've only got so much I can do.
Anything that's sitting around, whether it's in a tank, on a site, in a factory, anything that's not moving, right, is WIP, which is the opposite of flow.
Right.
And that's what we got to get our head around. That's what manufacturing figured out. If we look at those curves, we're flatline, manufacturing increase. What they figured out was flow, whether it was Ford with the assembly line, right? He didn't invent it, but he perfected it. He was all about flow. Toyota figuring out what they were doing, right, to reduce the batch and leveling and the rest. Those guys were all focused on flow. Because of the percent complete accounting, the earned value management, and the Taylorism about productivity through utilization, driving up utilization, right? So here's another thing. The higher we drive the utilization, the longer it'll take. What's a great example? The freeway. If you get on the freeway and we have a lot of traffic, we have high utilization, we're not moving anywhere.
Mm-hmm.
If you get on the freeway, 2 or 3 in the morning, you're probably flying down that thing. You got low utilization. So the utilization and then the variability between the stations that cause the WIP are really what you can work on, right?
Right.
So you can't even make it flow. You can't reduce time. You can't get more predictable. You can't make things flow. You can't do any of that stuff. All you can do is deal with what we call the 5 levers. Is the product design optimal to what it is you're trying to do? Can you work on the work process, right, including the tooling? So maybe a chop box is better than a handsaw. How do you manage your WIP? How do you manage your utilization? And can you do things to mitigate the variability? None of that has to do with putting a schedule together.
That is true. I think the only problem is that political process of trying to explain that to, said client or whoever, when you start talking about that, you say, I hear what your dates say, but here's the reality. And then, you get the pushback of, well, that's your problem, not mine. Okay, yeah, it's our problem. So again, how do we solve it? How do we get into it? And so I think that brings us to this whole idea of we're a brand new year, 26. We're staring down the age of AI. Like I say, there's already a bunch of data centers out there. A lot of them either are going to be looking for upgrades. Some of them are brand new builds. We've got an energy infrastructure issue. And the last thing that I think that we need to see is an explosion of cost. But I fear that, if we don't approach this properly, that's exactly what we're going to see is an explosion of cost because of working on a system that's 110 years old. We're working off of Gantt charts and, unrealistic schedules.
This is very, very scary times to me. And it's not. So there's people predicting another 2008 or 9 situation, right?
I've heard that.
And those are the financial guys that see this from a financial perspective. And they're like, this guy's selling to that guy and that guy's putting the money back in and it's a closed loop of the same companies.
Mm-hmm.
Okay. What concerns me, having been on many of these projects, knowing a lot of these people, is we're not doing anything different. The AI factory is not going to be running. Okay.
Mm-hmm.
And people aren't they haven't come all the way clean yet, saying that we have some delays. Now we're playing with numbers. Yeah, the numbers are staggering as you started with, right? And to think about this from a whole systems engineering perspective. And what I don't understand is why people don't understand this, but maybe because they just don't. First, we thought we needed to go build a bunch of data centers. Then we figured out we needed power. The first word of power is build power, whether it's build transmission, build power generation. We got build, everything's build.
Yes.
And everyone's saying, as you said, that's someone else's problem. But it's someone else's problem until there's no power. And a guy that ran a large co-location data center company lost his job because Dominion couldn't turn on the power. A guy that ran a large oil and gas company lost his job because they had two large projects where they couldn't get them up and running. And so there's a lot at stake here. But most important to me, which concerns me, is as I believe, and I think you're saying the same thing, as these projects, because we're not doing anything different, become delayed, we're making a huge bet. Okay.
Mm-hmm.
And I believe you're going to see it in the earnings of the guys that make the stuff, the OEMs that are supplying these projects. Now, you don't see a lot of capacity increase from the guys like Schneider and some of those other suppliers, Caterpillar. They're not off running to build plants.
No, they're not, because they can't build them in Mexico anymore.
Well, there's that. And they're not convinced the demand's going to be there because the construction part. And if you look at the guys that are financing this stuff, they're interested in financing GPUs. They're interested in financing maybe some power projects. But what they're not really, they're interested maybe in some data center development projects. But at the end of the day, this is all going to get down to the construction guys. And I don't know, I've been on a crusade speaking at many conferences related to data centers and energy saying, guys, the first word is build. And our industry, I'm in the industry, we don't have a reputation of being the stellar guys. I always say, thank God we're not delivering babies.
Yeah. Yeah. Well, I think that's what's interesting. It's not that there's not guys out there, capable of making it happen. And this could kind of lead into the idea of, we have a labor shortage. Yes, we've skilled labor shortage. We know that. We know that our skilled labor retirement age is coming to fruition as well. 1 for every 7 that will retire, we may have 1 that comes up through the trades that could replace those 7. That's okay. We can talk about that concern. I from my blue collar background, from my days in the hall working union, I know those guys out there. They're willing to work. They're willing to go get it done. That kind of thing. We got to pay them right, and get the work done. Then they just get the other side of it. Yeah, the other side of the construction, the project management side. Is there a shortage? And this is something that I still don't see McKinsey or Deloitte or any of those companies kind of really truly defining. Everybody says construction labor shortage. Is that a skilled labor shortage? Or are we really talking about project managers, folks, engineers, folks that are skilled at being able to truly develop and build something, like knowing how to build? Do they come out of school knowing how to build? And I don't know if that's true or not these days.
Well, I have some insight on that because you're actually asking a great question. Let me throw this out at you. And good friend of mine in the UK, we spent a lot of time with this. He runs one of the preeminent engineering firms in the UK, and basically has now spent his career cleaning up mega civil projects. Right?
Yeah.
They decided to assist at university and to teach students. He's saying around the world, students are coming out with engineering degrees that have never been on a construction site. A little mechanical, electrical. That's a scary proposition. So I would say you're alluding to an interesting thing. In my head, I chunked this into 3 buckets: knowledge workers, which we're going to call engineers. All right. Yeah. And we'll throw in architects. And I would say a guy that does detailed engineering who may have been a journeyman pipe fitter that's working at a CAD system. I'm going to call that guy an engineer guy. Okay. Mm-hmm. Then we have craft guys. And those guys actually cut things, weld things, bond things, wire things, do whatever they do. Okay, it's pretty clear. And let's throw the logistics guys who are operating cranes, driving trucks. Okay, the blue collar guys, and we got the thinker guys. Those guys typically get along pretty well. You know what I mean?
Mm-hmm.
Those thinker guys have a lot of respect for those doer guys. And those doer guys are like, hey, can we do it this way? And usually the thinker guys going, I see what you're talking about. Now in the middle, we got what I'm going to call the administrator guys. And we have no shortage of administrator guys. And in my opinion, we could get rid of 85% of those guys and go back to what we did have back in the day, which is the thinker guys and the doer guys who actually like to work together because they're doing what we call building shit. right? And it's pretty, my opinion on this is pretty fucking clear, right?
Right.
There is people that design shit and people that make and install shit. And then there's guys in the middle that I don't know what the fuck they're doing. But I could tell you this, if we had a shortage of the guys in the middle, that would be the best thing that happened to us.
Yeah.
Okay. Because there's not a lot of guys out there, and I'm sure you're one of them, that want all the materials delivered to your work face,
Yeah.
right? And a bunch of guys you don't need. By the same token, you don't want a starving amount of materials or not enough guys, but you kind of know what you need, right?
Yeah.
And you start figuring out really quick, like that drill isn't really, that self-tapping screw is not going into that carbon steel as fast as they said, or, they said it would penetrate 316 stainless. It doesn't do that, right? So we better refigure this.
Right.
We better rethink this. So I would say, do we have a shortage of thinking guys? Absolutely. Do we have a shortage of guys that do stuff? What's interesting on that one with regard to the data centers and now the energy is we had a lot of electrical guys in the data center space. If we move to liquid cooling, we're going to need a lot more guys that do piping type work, right? Power plants have a lot of pipes in them, right? So we could even bifurcate. Do we need more concrete finishers or carpet layers, or do we need piping guys, right? But those guys in the middle, those administrators, I hope that we do have a shortage and we can never replace them.
It's a great point. Seriously. It is a great point. And this is something I want to remind my audience about and let everybody know. Look, folks, we talk a lot about this. We may talk and we talk a lot of shit about, hey, if you're just an administrator, please get the hell out of the way. And there is something that you can do if you're an administrator, that is get involved. Maybe learn from those superintendents, shut your mouth for a little while, learn something. If you're just out of college, and they probably haven't taught you exactly what you need to know, probably the best thing that you could do for the first 6 weeks is to just shut up and listen and learn something and become a valuable asset. And in whatever that capacity is, because it is true. And no matter how much people want to gloss it over and they want to tell you, we need all these different things. The truth is what we need people that solve problems, the thinkers, and we need people that are doers, people that can install it. That's what we need. And we especially need it right now. And the ultimate effect is it's really going to rest on the shoulders of those folks that can do that, because the administrators will be the first one to tap out when it gets hot. And it will get hot, and that's what's coming if you don't understand it. 2026 will be the beginning. We've got mandates for 2030 of when we're supposed to be trying to get stuff done, and I'm telling you right now, this stuff is coming in hard and fast, so you better be ready when the time comes. So, yeah. I know that 2026 this is going to be a great year, but it's also going to be very, very challenging for a lot of folks because we're going to start to see some of the chinks in the armor. And so the reason I wanted to start off with this podcast with you, Todd, is because I knew you'd tell it like it was. Because I want people to understand there is a methodology out there. There's ways that we can do this. We have to shift our mindset. We got to get out of that schedule mindset. We got to get into that rate mindset. How much can we get done with what we have? Because to your point, that bottleneck is what we have to deal with. It's the valve. It's the very thing that is going to say whether we can turn it up or turn it down. And how do we do that?
And let me throw this out. We're involved in some projects where there was one that we're working on. I mean, this is very standard for us when we start to apply the production stuff. But there was one the other day, not in the U.S., a massive project, a civil engineering project, civil works project, that they were able to take 70% of the time out. Okay. It's not uncommon for us to see 50 and 70% time reductions and 30% cost reductions, but it's by focusing on the work, right? And tapping these engineers with problems and saying, we need a way to connect this with this. We're just saying connect, right? Now you tell us we fuse it, we epoxy it, we glue it, we screw it. We need to, this operation is the bottleneck. And those guys will say, let's work together. And they have no dog in the hunt. They're like, as long as it's going to be sound, let's work together. So we need, in my opinion, to get those doers and get those thinkers back together and get these administrators out of their way, as you're saying. Now, I would just add one thing to what you said, what someone told me a long time ago. If you have a passion for this kind of stuff and you want to be involved, go to work for a specialty contractor. And I would say a mechanical electrical contractor, because they do engineering, detailed engineering, they do fabrication, they do installation, they do commissioning.
That is
And when
correct.
shit gets sideways, they get a call. And so when you go back to the administrators, and whoever the administrator works for, when there's a problem, what do they say?
They're going to call somebody
More
else.
men or the design screwed up. And I'm going to tell you the most profound administrator thing I ever heard. We were doing the PPI, the Project Production Institute symposium a few weeks ago, and a mechanical contractor told an owner, you should check this out. I think it would be really worth your time if you had it play in the background. The guy says, sound great. Can you send more men? And the whole purpose of what the guy wanted to hear was, why don't we talk about flow? He says, sound great. Can you send more men to the site?
Yeah.
He's like,
yeah, didn't get it. Right. Again, you can lead a horse to water, can't make him drink. The old cowboy thing. I think it's very appropriate. Again, I think it's a great way to start off this first episode, which is kind of, get our stuff out in front of us. Let's talk about what we can do. But let's talk about the obstacles that are in front of us, because we do have some obstacles in the industry, and they're very, very big. It's a little scary, but we got it. If we don't talk about them, if we don't discuss them, if we don't start to share this information, we end up worse. But that's why the next podcast, we're going to talk a little bit about the kind of the hidden factory within every job site. There is a way, and we're going to get a little bit more into that manufacturing idea for construction, help folks get a better concept of it. And I love the fact that you're doing this with me, because again, 35 years of experience in this world. I'm talking to the experts here, and everything that you say always resonates with me, because I can always think about jobs that I've done in the past. Your stainless steel reference is like, hey, yeah, we're not going to be able to self-tap that through that stainless steel. I look back, I remember a job specifically where I was like, well, this ain't going to work.
absolutely. I used to be a specialty contractor, and we would read those fastener data sheets, and we had our office in a high-rise building. We'd be in there with a screw gun with a piece of, whatever. And now it's going to go. I go, this shit ain't going in, right?
Yeah.
And people look at guys like you and me and say, why do you care whether that self-tapping fastener goes in there or not, or how long it takes? Well, we got to put in 27,000 of them.
Yeah, we got 27,000 of them to do, yeah.
Yeah, and 15 seconds is a lot different than 3 minutes, or having to go out and drill the thing, right? A pilot hole or whatever, and then put this thing in, change the guns, all the stuff that you had to do back in the day, right?
Right. And it makes every bit of difference, especially when you're, by the end of the day, like if you've been trying to pilot, you didn't pilot them through, or you've been trying to press on that self-tapper all day, and you had to go through 3 screws just to get to the one that finally went in, right? And your hand is, a piece of grindered meat. It's like,
shit's breaking off.
Yeah.
You got to pilot hole the thing. You got bits down below. Shavings below.
Yeah, the break
goddamn
off.
CM telling they're going to back charge your ass for cleaning because they're trying to make a profit off it.
Yeah.
This shit goes on and on, right?
Yeah,
fun.
But the average doesn't understand. Like, why didn't that work? What? Can you not just trust me on the fact that I know this doesn't work, because I've been down that road and been there, done that, not working.
I swear to God, it's like fasting is a fascinating topic. We're involved with a customer right now. The building is 300 meters by 120 meters, okay? And it's like 80 meters tall. They said, what do you think? I said, you got a fasting challenge. We got to figure out the fastening.
That's right.
And I said, it's the how we're going to attach the steel and how we're going to go put all the cladding on this thing.
Yeah.
So, well, we're going to jack it. I go, yeah, the jacking's great. I go, we could all figure out how you're going to jack it. The screw guns are the problem, right? We got to look at robotic screw guns.
Yeah.
And they're like, yeah, but we're going to jack it. I go, I know we're going to jack it, but how are we going to put this siding on and this roof on, right?
Yeah. How are you going to get it closed in? Yeah.
Right.
Yeah. So again, it goes down to the whole thing. There's tons of problems to solve in the construction world, and we are welcoming anybody who is a thinker and a doer. That's who we're looking for out there. So if you've got people that are thinkers and doers, let's get them involved, get them out there working. That would be great. But until next time, Todd, thank you so much for spending your time with me today. I can't wait for the next one. It's going to be exciting, and I'm looking forward to it.
Well, thank you very much, and we're looking forward to and enjoy the time till we get together again.
All right.
Thank you.
Everybody out there, be safe out there on those job sites. We'll see you next time on the ConTech Exec.